We're going to sketch a graph of this. We've got cosine of t and tangent of t. Then change the window. The period for cosine is 0 to 2 pi. For tangent, it would be negative pi over 2 to pi over 2, but if you do 0 to 2 pi, then that's more than enough to cover all of tangent. So 0 to 2 pi should be enough. This number right here is, right now I changed it from its default. Its default is pi divided by 24. Then cosine doesn't get very big, so the x's are going to range between -1 and 1. I'll make it go -3 to 3 to make sure I can see everything. The y values are tangent, which tangent goes to infinity. So perhaps having the y values -10 to 10 will be good enough. And then take a look at the graph, and it seems to be sort of a diamond-shaped object, except it's going to go up there. So we'd have so it seems that whenever it got to this point right here, dy dx would be undefined. That's like a sharp point or a cusp. Okay, but the goal of this one is not to do calculus, it's to next eliminate the parameter t. So in other words, get rid of t. Change this back to the xy system instead of the xyt system. So we need to use some kind of trig identities to somehow get rid of the trigonometry. Well, there's things like sine squared plus cosine squared equals 1. The only problem is I don't have sine and cosine, I've got tangent. There's things like 1 plus tangent squared equals secant squared, and I do have a tangent, but I don't have a secant. But I could get a secant by inverting this. So take this one, invert both sides, and it would say 1 over x is equal to secant. And then I could use the identity 1 plus tangent squared is equal to secant squared. Or in other words, if I had secant squared minus tangent squared, then secant squared minus tangent squared could be replaced with just a simple 1. So secant is equal to 1 over x, tangent is equal to y, so just put that information in here. So we've got 1 equals, replace the secant with this, it's going to have to be squared, minus, replace the tangent in this with a y, and it also has to be squared, and then that would be it. And I could try to verify by graphing this in the xy system and see if it gives a shape that looks like this. So let's see, I would need to solve for y. I'll move the y to this side, 1 over x squared, and then it's going to be minus a 1. And then that sort of makes sense. If you look at this, when x is 0, there's going to be a vertical asymptote. Well, when x is 0, that's right here, and there's our vertical asymptote. Now to have a graphing calculator graph it, I'm going to have to do y equals plus and minus the square root of this. So let's change the calculator back over to the xy system. And we've got the square root of 1 divided by x squared minus 1. And then we've got negative of that. And if you don't want to type the whole thing, you can go right here to variables, go to the y variables, and then it says, I'm going to do negative of what you said y1 is. And let me check the window. Well, what I could do is just go zoom 6. It does seem to be the same shape. I'm zoomed out right now, But let me zoom in a little bit. I think on the other one I was at -3 to 3 for x's. It draws it in a slightly different way. I mean, the ending shape is the same. The other one drew it not in the same exact order, but it does seem to be the same. So there we go. Whichever one you want to use.